When NASA released the confidential findings of their latest propulsion test, the scientific community braced for a ripple. Instead, what followed was nothing less than a tsunami. After decades of chasing the dream of faster-than-light travel, the veil had finally been lifted, revealing what many had whispered about in secret corridors and debated endlessly in theoretical physics forums. NASA had developed a propulsion system so advanced, so fundamentally revolutionary, that it could reach the ultimate frontier, light speed itself. Not near light speed. Not relativistic speed. Actual light speed. 186,282 miles per second. The implications of this admission are staggering, threading together the audacious dreams of science fiction with the increasingly bold trajectory of modern physics. At the heart of this breakthrough lies a propulsion system that transcends everything humanity thought possible about movement through the cosmos. NASA's engineers, collaborating with an elite cohort of quantum physicists, AI specialists, and material scientists, constructed a prototype engine rooted in principles that were once dismissed as fantasy. They had seemingly harnessed the elusive qualities of zero-point energy and quantum vacuum fluctuations, phenomena that tap into the hidden ocean of energy present even in the emptiest voids of space. For decades, this energy had been described in theory but dismissed as untouchable, immeasurable, and impossible to control. Yet through advances in quantum field manipulation and the development of metamaterials not found in nature, NASA had managed the impossible. They tamed the void. The result was a drive mechanism unlike any rocket ever conceived. It required no fuel in the traditional sense. It did not push against the emptiness by expelling mass. Instead, it reconfigured spacetime itself on a controlled scale. In many ways, the technology echoed the Alcubierre metric, a theoretical model once confined to the fringes of physics. According to that model, a spacecraft could move faster than light by bending space itself, compressing it in front while expanding it behind. The craft would remain stationary inside a bubble of warped spacetime, with space itself doing the moving. The light drive, as NASA engineers now call it, transforms this mathematical fantasy into tangible engineering. Light speed remains the universal limit inside the bubble, but the bubble itself bypasses that restriction, riding the fabric of reality like a surfer on an endless cosmic wave. For years, the experiments that led to this breakthrough were hidden under layers of secrecy. Code names disguised research projects, funding was buried within the labyrinth of deep space propulsion initiatives, and test results were locked away in restricted archives. Rumors trickled out, strange energy fluctuations, unexplained test anomalies, whispers of controlled warp bubbles. Fringe scientists speculated, conspiracy theorists shouted, and eventually, the leaks became impossible to ignore. Faced with mounting speculation and a growing body of undeniable data, NASA finally made its bold admission. But even in its official statement, careful wording and disclaimers filled the press release. They described the findings as exploratory and preliminary, but the scientific world wasn't fooled. The shockwaves of the revelation were unstoppable. At a test facility far from the public eye, the experiment that changed history took place. A prototype vehicle, no larger than a family sedan, was placed inside a vacuum chamber reinforced with magnetic field stabilizers. The calculations predicted that if everything worked, it might achieve 70% of light speed, a feat that would already shatter records. But what happened surpassed all predictions. The craft disappeared in a flash of brilliance, crossing the threshold of light speed itself. High-speed sensors, operating at over 1 billion frames per second, confirmed the unimaginable. For a fraction of a second, the vehicle occupied a relativistic frame, and then it was gone. Not destroyed. Not vaporized. Simply, gone. The data it left behind would occupy teams of scientists for decades to come. The implications of this discovery are staggering. The tyranny of distance in space, the brutal limitation that has chained humanity to its solar system, was suddenly broken. Alpha Centauri, our nearest stellar neighbor at 4.37 light-years away, has long stood as a cruel reminder of cosmic isolation. With current propulsion, the journey would take tens of thousands of years. With the light drive, that same journey becomes possible within a single human lifetime. In just over 4 years, an expedition could stand on the doorstep of another sun, staring at alien skies. For generations raised on Star Trek and Star Wars, this is the moment where fiction collides with reality. The challenges overcome to achieve this propulsion were monumental. Extracting and stabilizing zero-point energy without causing catastrophic instabilities seemed impossible. But NASA's scientists developed a revolutionary containment lattice, constructed from programmable metamaterials capable of adapting to quantum stress in real time. These materials, engineered at the atomic level, can bend electromagnetic fields and sculpt energy signatures on demand. Using them, researchers were able to generate and sustain a quantum vacuum gradient, a necessary step for creating the spacetime compression required by the drive. Navigation was another nightmare. Traditional spacecraft rely on inertial guidance and reaction control systems, but at Lightspeed, those tools are useless. To solve this, NASA built an AI-assisted navigational matrix unlike anything before. It doesn't merely react to obstacles, it predicts them. Using quantum entanglement-based data and gravitational mapping beyond the visible spectrum, the AI anticipates distortions, gravitational wells, and cosmic anomalies before they even appear. It essentially sees the universe seconds, even minutes, ahead of real time. Then came the issue of time itself. Einstein's relativity predicts that as objects approach light speed, time dilates, slowing dramatically compared to observers outside the craft. But the light drive's warp bubble insulates its contents. Inside, time flows normally even as the bubble itself races through space at light speed. This solves the paradox of relativistic travel. A crew could make the journey to Alpha Centauri in just over 4 years and experience every moment as if they were simply traveling across Earth. No decades of lost time. No future shock. But the implications go far beyond science. They touch philosophy, society, and destiny itself. Humanity's view of the stars has always been painted with a sense of distance and longing. The stars were eternal, unreachable, godlike. Now, they are destinations. The galaxy, with its billions of stars and countless potentially habitable worlds, is suddenly within reach. What does it mean to be human when our boundaries stretch beyond the solar system? What does civilization look like when interstellar travel is not only possible but practical? Families may one day live across light years, children could be born on ships between suns, and humanity's story will no longer be confined to Earth. Yet this revelation also ignites new conflicts. Space has always been a stage for competition, but this changes everything. The nation, corporation, or coalition that perfects the light drive first could control access to extraterrestrial resources, habitable exoplanets, and scientific frontiers. A new space race begins, not about who can plant a flag on the moon, but about who will claim the stars themselves. NASA's timing is no accident. Around the world, rival space programs are accelerating their own exotic propulsion experiments. The disclosure is both a warning and a challenge. The race is on, and the prize is no longer just orbit or Mars. It's the galaxy. The psychological impact may be even greater. For millennia, humanity has looked to the night sky with reverence, awe, and humility. The stars were untouchable, symbols of the divine and the mysterious. Now, that sacred distance is dissolving. The stars are no longer unreachable, they are invitations. With that comes responsibility. How will we engage with new worlds? Will we preserve, explore, and learn? Or will we repeat the mistakes of colonization, exploitation, and conquest? These questions are no longer hypothetical. They demand answers, and soon. Perhaps most importantly, the light drive forces us to rethink the very laws of physics. For over a century, scientists believed the speed of light was an unbreakable limit. But NASA's engine doesn't break the rule, it bends it. It sidesteps the limit by rewriting the playing field. This not only validates alternative interpretations of quantum field theory but also lends credibility to ideas once dismissed as fringe. Suddenly, theories about dark energy, exotic matter, and even the unification of gravity with quantum mechanics seem far less distant. The line between science and science fiction has never been thinner. It is impossible to overstate the scale of this moment. Light-speed propulsion is the key that unlocks the galaxy. Entire worlds, once just faint dots in telescopes, are now real possibilities. Colonization, observation, preservation, these are no longer distant dreams but emerging realities. Humanity stands at the threshold of a future where Earth is just one of many homes. Yet the light drive also presents dilemmas. Who decides where to go first? Who owns the technology? How do we balance discovery with responsibility? These questions will shape global politics, space law, and ethics for generations. But amid all the complexity, one truth shines brighter than the rest: curiosity. The same human drive that led our ancestors across oceans and into skies has now carried us into the stars themselves. The light drive is not merely a machine, it is a symbol. A vessel of our need to explore, to push beyond boundaries, to answer questions older than civilization itself. The final frontier is no longer a metaphor. It is a map coordinate. And with each step forward, we illuminate the darkness not just with light-speed propulsion, but with the oldest and most unstoppable force in the universe, the human spirit.